We start. Aloha! Welcome to the Galaxy Cruise Live. My name is Kumiko Sato, a public outreach specialist at Subaru Telescope on the island of Hawaii, and helmsman of the Galaxy Cruise project. Galaxy Cruise is a citizen science project of the National Astronomical Observatory of Japan, NAOJ. Citizen astronomers classify galaxies captured by the Subaru Telescope on Mauna Kea, Hawaii. As you may have participated in the 2023 special campaign, classifying simulated galaxies from September 2023 to April 2024. Today, Dr. Makoto Ando-san, a navigator of Galaxy Cruise, will report the preliminary results of their analysis. He is a project researcher of Subaru Telescope and a science team member of Galaxy Cruise. Hi, good evening, Ando-san.
Hi, aloha.
Hi, aloha. How are you?
Hello, everyone. My name is Makoto Ando. I am a navigator or the science team of this Galaxy Cruise project. So today I want to show you some the preliminary and some initial result from our 2023 the special campaign for classifying the simulated galaxies conducted in the last year to the early this year. So I hope all of you enjoy today's short report from me and enjoy the Galaxy Cruise, the galactic ocean of our project. Thank you.
Thank you so much, Makoto-san. So, our captain, Masayuki Tanaka-san. So, working with Captain Tanaka, Ando-san led the special campaign for simulated galaxies. So, Makoto-san, could you start? Please share the screen.
Sure. Okay. Now I'm showing my screen. Can you see me?
Yes.
Okay, so let me start today's presentation. So as I mentioned earlier, today I want to show you the initial result of our special campaign conducted in the late last year to the early this year. And so today, okay, I have several contents. The first one, I want to show what is the Galaxy Cruise and the motivation of the Galaxy Cruise project. And then I want to talk about what is the simulated galaxy. This is a main component of this special campaign. And third, I want to talk about what is the special campaign. And at last of this presentation, I want to show you the initial result from this campaign. Okay, let me start with the beautiful images taken by the Subaru Telescope, which we base on the Galaxy Cruise project. So this galaxy is taken by the Subaru Telescope, the Hypash Prime Cam. This is a spiral galaxies. You can see the beautiful spiral structures in this galaxy. This is a different type of galaxy called the elliptical galaxies. The elliptical galaxy have a rounded shape, and it do not have a kind of the arm-like structures different from the spiral galaxy. And so this is the main focus of this Galaxy Cruise project. This is an interacting galaxies. So in this picture, there are two galaxies at the center, and these two galaxies are now collided with each other. And some extended structure is extended beyond the galaxy main body, like this and like this. And also, this is the interacting galaxies, and this have a tail-like structures towards the bottom left direction. So these two galaxies are collided with each other, and because of the gravitational effect, some stars are stripped towards the bottom left direction like this. So these interacting galaxies are main focus of our Galaxy Cruise project. The definition of the interacting galaxy is very simple. That is, the galaxy is colliding with other galaxies. And this interaction, galaxy-galaxy interaction or collision is very important because it have great impact on the galaxy morphology or shapes, as well as the galaxy some activities like forming new stars or the black hole activity at the center of the galaxies. So this interaction is very important for understanding galaxy evolution or galaxy growth, but for better understanding of the role of the interaction on galaxy evolution or formation, we need a large sample of the interacting galaxies. So Galaxy Cruise aim to derive a large sample of the interacting galaxies based on the beautiful Subaru Telescope's images. So Galaxy Cruise have the classification scheme of the interacting galaxies based on the shapes of the galaxies. So participants or citizen astronomers first looking at the galaxy images, and if you find ring-like structures, tail-like structures, fan-like structures, or distorted morphology of the galaxy, you can classify that galaxy as interacting galaxy. So thanks to the very high quality of the Subaru imaging, so you can capture the very faint features around the interacting galaxies. So this bottom panel shows the images of the interacting galaxy seen by the Subaru telescopes. And if you compare with these interacting galaxies with the images of the previous generation telescopes, yeah, you can find a great difference between these two. And the Subaru telescope successfully captured the interacting features around the galaxies.
Makoto-san, let me confirm. So the upper image and the lower image are the same galaxy. And the
Yes,
upper galaxy is captured by different, smaller telescope. So on this galaxy
yes.
survey. And the Subaru has the 8.2-meter aperture. So we can collect more light, we can detect fainter structure. Am I right?
Yes, exactly. That's a very strong point of the Subaru telescope. Yeah, it have a large mirrors, so it have a high so it have a capability to capture the very faint features like interaction features.
Yeah, so generally the interaction feature like distortion or tail are very faint. So Subaru telescope successfully detected these faint features of interaction. Thank you so much. Please go ahead.
Yeah, thank you. Yeah, that's a good point. And so we have two classification steps. So participants first classify the galaxy morphology into the spiral galaxy or elliptical galaxy. And at the second step, participants classify the galaxy interaction. So interaction galaxy or not interacting galaxies. And for the classification for morphology, it's very successful. This plot shows the histogram or galaxy number distribution of galaxies which are selected selected as a spiral galaxy according to your vote in the Galaxy Cruise classification. So in this plot, the horizontal axis 1 means that all people say it's a spiral galaxy. And 0.5 say the half of people say it's a spiral galaxy, and 0 means that all of people say it's not a spiral galaxy. I mean, it's a elliptical galaxies. And yeah, actually, it is well known that the elliptical galaxy have red colors and spiral galaxy have blue colors. So we can say that red galaxy is likely to be an elliptical galaxy and the blue galaxies are likely to be a spiral galaxy. So if we assume that color is a good indicator of the galaxy shapes, we can say the color can be used as answers for the morphology or shapes of the galaxy. So based on this idea, we can say the blue galaxy are successfully classified as a spiral galaxy according to your vote. On the other hand, the elliptical galaxies, so red galaxies, are classified as an elliptical galaxy according to your boat. So we can say the spiral galaxy and the elliptical galaxies are clearly separated according to your boat. It's
So
good.
Makoto-san, it means so the classification results by student astronomers are excellent.
Yes, exactly.
Great. Thank you so much for classifying. Yeah, it looks great. So the morphology, elliptical or spiral, it's easy to separate, distinguish.
Yes, by a combination of the good quality Subaru imaging and the eyesight of your student scientists, student astronomers.
Yeah, sounds great. Please,
Okay,
yeah, please go ahead.
so actually we are very happy to see this spiral galaxy elliptical galaxy classification, but the problem is exists on the classification of the interacting galaxies. So this is the same plot. The horizontal axis says that the fraction of the people saying this galaxy is interacting galaxies. And this is a number distribution or histograms. Actually, there are some galaxies which are clearly interacting galaxy, and almost 100% people say this is a interacting galaxy. Yeah, it's good. But unlike the case of the galaxy morphology, which we have answers of or indicators of the correct answer, this interacting galaxies do not have any indicator or answers for the classification. So it's very difficult. Where should we draw a border to say, yeah, this galaxy is an interaction galaxy or this galaxy is not an interacting galaxy? I mean, so if although people say it's a interacting galaxy, I think it's good. Yeah, that may be interacting galaxy. But if 80% of people or 70% of people or 60% of people say it's a interacting galaxy, so I don't know, is it reliable or not? So this is a problem in the interaction galaxy classification.
All right, so the two graphs show very different. So the morphology, elliptical or spiral, it is very clear which is which, but interacting or not interacting, it's your boat is very continuous and hard to separate. This is interacting, this is not interacting. It's hard to tell. So this is
Yes,
your motivation to start simulated galaxy, to classify simulated galaxy.
yes, exactly. So the problem is we do not have a correct answer for the classification of the interacting galaxy. This is a point. So actually, in the real universe, we do not have any correct answer for the classification of the interaction. However, we came up with one idea that is, if we use the computer simulation, we may have a correct answer for the interaction. So a given galaxy is interacting or not. So
Excuse me, sorry to interrupt you, Makoto-san. I
yes,
received one question from Majax-san. Thank you so much for your question. I read Majax's question. Please, could you go back to the blue and red galaxy morphology classification? Uh, the blue or red color is because of the composition of galaxies, like uh, elliptical being older, or is it more related to redshift?
yes, actually, this is the component of the stars. Yeah. So the former is correct, not the redshift effect. Yeah,
Yeah.
because the elliptical galaxy have old stars. The old stars have a red color, and spiral galaxy typically have young stars, and the young star have bluer colors. So this is why the elliptical galaxy typically have a red color, and the spiral galaxy typically have a bluer colors.
Thank you so much. So in Galaxy Cruise, we selected nearby galaxy. So that the redshift is less than 0.2 or something, right? So the almost same distance. So the almost same redshift. Thank you so much for asking a very good question. Makoto-san, please continue your presentation.
Okay, thank you for great question. Maybe you are expert of this field.
Yeah, I think so.
Yeah. Okay, so let me come back to the point. So in the real universe, we do not have a correct answer for the interacting galaxies. So we try to use the simulated galaxies. The galaxies reproduced in a computer simulation. So I'm going to show you what is the simulated galaxy. So this is this is a movie, and this movie is come from the computer simulation called the Illustrious TNG. Let me start. So on the top left, the spiral galaxy is here, and on the bottom right, the elliptical galaxies are here, and these two galaxies are attracted to each other by gravity. And the time of close encounters, the morphology of these two galaxies significantly changed, and the tail-like structures appeared, and the distorted morphology of fan-like features found. And at the end of the interaction, these two galaxies merge into the one single spiral galaxies. Okay, let me see again. So spiral galaxy here, elliptical galaxy here. These two galaxies are gradually become closed, and now collided with each other. The interaction here is just tail-like structures, and many stars are scattered due to this interaction. And finally, there is no significant interacting feature around this single spiral galaxies. So what is important here is that in the computer simulation, we can trace back of this history of the interaction from before the interaction stage, during the interaction, and after interaction, the end of the interaction event. So this is a point. So if we use the computer simulation, we can define the correct answers about whether a given galaxy are interacting or not. This is a very important point of the computer simulation. So if you classify the galaxies come from the computer simulation, yeah, you can say it's an interacting galaxy, or this is not an interacting galaxy, and simulation tell us the answer. So we can check the reliability or accuracy of our classification. This is the idea to check the reliability of our galaxy cruise classification. So based on this idea, we started the special campaign to classify the simulated galaxies. So this campaign is aimed to check our reliability of our classification scheme using the simulated galaxies instead of the real galaxies. This campaign is launched September 2023 and ended in March of this year. So thanks to many participants, we successfully collecting the 400,000 classification for over 7,000 galaxy images. This is very great. Yeah, and I'm very happy to collect these many classification. I really appreciate all of the participants and the people who are interested in this special campaign. And from now on, I want to show you some initial result of the scientific analysis based on these classification data. Okay, let's go. So this figure is our main focus. And this is actually a little bit complicated, so I want to explain one by one. Okay, first, the horizontal axis shows the time since the galaxy interaction or collision. So 0 means that the interaction happened now, right now. And the right-hand side is all the collisions. So time has passed, so 1 billion year or 2 billion year from the collision happen. So, vertical axis shows the mass ratio of the two interacting galaxies. One means the collision of the same mass galaxies. And so 1/10 means that the galaxy mass ratio is 1/10. This is a very important point to classify the galaxy interaction. So please imagine that two big things like two big animals, elephants, are collided with each other. If the size or the mass of two elephants are same, these two elephants suffer from the significant impact on this collision. But if the collision is occurred between the elephant and the ants, very small ants, then these elephants do not suffering from any strong effect from this interaction, or not the interaction, but the collision. So the situation is the same for the galaxy collision. So if the same mass galaxies are collided with each other, the shapes of the galaxy are significantly changed and distorted. But if the larger galaxy collided with the very small galaxy, there is no impact, or very, very small impact. So this mass ratio is also very important. And at last, the color shows a fraction of people saying this galaxy is an interacting galaxy. Okay, now I hope you understand how to see this plot. So I want to show you some trend we can see on this plot. First, this top left corner. This corner shows that the collision happened recently, and the mass ratio between two galaxies are similar or same.
All right.
And
So Makoto-san, let me confirm. So the red color means surely interacting. So
yes,
many people voted interaction. So the same mass and just after collision, it's easy to detect the features of interaction. Am I right?
yes.
Thank
So
you.
yes, we expect that this region are dominated by the red point, and actually the result are consistent with our expectation. The red point, in other words, the galaxies, the interacting galaxies feature easier to find, is clustered onto this top left corner on this plot.
Makoto-san, I have one question. So
Yeah.
we see many tiny dots. So in the same area, there are a couple of dots. So one dot corresponds to one galaxy. Am I right?
Yes, partially yes.
Partially,
Actually, we
okay.
have the computer simulation. We can see the one galaxy from a different direction. So these 4 points actually clustered at each place, and each 4 points shows the one galaxy. Yes.
Right.
But in
Yeah,
any
this
case,
this is our secret, right? So
yeah.
at the beginning of special campaign, we ask student astronomers just classify these galaxies. But in fact, four galaxies with different inclination. So one galaxy with four different inclinations. So Makoto-san compile all your results and make just one galaxy with four different inclination. Am I right?
yes, correct.
Okay, thank you so
But
much.
yes, and basically the trend is very simple. The sometimes the galaxy classification is significantly changed according to the different viewing angle, but basically the classification is consistent even if you see the same galaxy from different viewing angle. But yeah. So and I want to emphasize here is that the galaxies which Galaxy Cruise classification scheme can detect is clustered in the top left of this plot, top left corner of this plot. Yes. And the second idea, that is the recent interaction, but mass ratio is large. So the mass of the two galaxies are largely different. In this case, the bluish point or greenish point, which correspond to the 10% to 15% of people say it's an interacting galaxy. So such galaxies are clustered in this bottom left region. So if the collision is happened recently, if the mass ratio is large, then it's very difficult to classify. Even if the even so even even if the so Subaru have a good quality imaging. And just lastly, on the right hand side, this is a very old collision. So in this area, the many blue or greenish points are clustered. It says that all the collision are actually very difficult to detect. And this is actually consistent with our expectation. After the collision, the galaxy interaction features will disappear gradually according if the time passed. And yeah, this result is actually consistent with our picture. But we can find some exceptions, like here, here, and here. Yeah, this is actually very, very interesting for me. So if the ancient, very old interactions or mass ratio is very different, then some interaction can be found using the good quality spar imaging and your capability to find, so the participants, the capability of finding the galaxy interacting features. So now I want to show you some example of the interacting galaxy picked up from this plot. So first is a very recent collision, and the mass ratio is similar to 1 by 1 to 1. So this galaxy is that example, and the almost 100% people say this is an interacting galaxy. And actually, you can see the clear tail-like structures, the one of the interacting features in the Galaxy Cruise. Yeah, this is good. And if you pick up the recent collision, but the mass ratio is very large, then so it's very difficult to find its interaction. 80% of people say it's not interacting. And actually, to be honest, I cannot find any interacting features around this galaxy. So it's very difficult to find such large mass ratio interaction. Okay, the third idea, the very old collisions. This is also very difficult to find any features. Only 30% of people say it's interacting, and 70% of people say it's not interacting. And actually, I agree with this is not the interacting, but actually, simulation says that this is interacting galaxies. So we can find that the very old collision is also very difficult to find. But there are some exceptions, as I said earlier. Let me see this exception one. This is very interesting. So this is a collision happened 1.5 billion years ago. Yeah, very old collisions, but almost 90% of people say it's an interaction. And actually, there are fun-like features at the top of this galaxy and the bottom of these galaxies. Very clearly seen these features. This is very, very interesting for me. Yeah, even if the mass ratio is very large, so it's a 15 times 1, and the collision is very old, but we can find some features. Yeah, this is very surprising for me. And the exception number 2 this is also the order and the different mass. Yeah, these galaxies are classified as an interacting galaxy based on the 96% of yes, this is an interacting galaxy. And actually focus on this central part of this galaxy, the spiral arms are distorted towards the bottom right direction. Yeah, this is actually interacting galaxies. So I'm actually very confused why these features are seen, even if these collision are happen very, very old days. So this is a summary of what we learned from the initial analysis of this special campaign. So first, the Galaxy Cruise mainly detect the recent and similar mass interactions. This is actually we expected before this campaign. But secondly, very, very surprising to us, the Galaxy Cruise also captures very, very old interaction with a large mass difference. And so as a conclusion, I can say that the Galaxy Cruise classification is much better than we expected. We can capture the very, very old interactions. And it's very interesting and therefore investigate much more further. So I want to see why we can see such a very old ancient collisions from our images. But actually, scientific analysis goes on. We have many things to analyze before we writing a scientific paper, but we work very hard to publish our result on the scientific journals. So please stay tuned for our future announcement that we writing a paper and we submitted a paper and our paper is published, something like that. Okay, so at last of my talk, I want to announce two things. So the summer activity of our Galaxy Cruise project. The first one is Galaxy Cruise Season 2 is ongoing, so please join it and enjoy the Galaxy classification. And actually, we started the TNG review course. This course is focused on the simulated galaxies, which are used in this special campaign. And you can compare your classification, and the classification comes from the computer simulation. So this is, I think, also interesting, so please join it. And the second announcement is that the special campaign for this summer. So as usual, we held the Classify 1000 Galaxy 1 month campaign at this August. So you can get a special illustration celebrating the Subaru's 25th anniversary that starts from Subaru first observation. So please enjoy the classifying galaxies on the Galaxy Cruise. And I hope all of you enjoy the beautiful images that come from the Subaru telescopes. Yeah, that's all of my talk. Thank you.
Yeah, thank you so much, Makoto-san. It sounds very interesting. So you detected unexpected features of interaction for very old collision. So yeah, I look forward to the next your result. Yeah, and also Makoto-san announced we will start the annual Classify 1000 Galaxies in months in August. Please join us and look in the background. We show the Subaru 25th anniversary special logo. So this year we celebrate its 25th anniversary since its first flight in 1999. And please classify more than 1000 galaxies and please complete this 25th anniversary logo. And yeah, thank you so much. So can I have some additional announcement? Okay, so I want to share the screen. Wait a second. Okay, I want to share my screen. Oh, wait a second. Okay. This is not. Oh, okay. The first one is so our public Subaru Telescope Public Information Outreach Office promoting a couple of 25th anniversary projects. One is we release 2 new images of the captured by Subaru Telescope per month. So please visit our website and please click Subaru Gallery and you see many new images. So most of images are captured by Hypersh Prime Cam, HSC, same as Galaxy Cruise. So you may know some interacting galaxies like Jellyfish Galaxy, and also this one. This is our result, first result in season 1. Captain Tanaka, Makoto-san, and other scientists published very first scientific paper. So please visit our website and enjoy many beautiful images captured by the Subaru Telescope. The next one is we have just released a new video, only 5-minute video commemorating Subaru 25th anniversary. So please, you can watch this video at our YouTube channel. So please go to our YouTube channel and enjoy the 25th anniversary video. And please follow us. We have YouTube, X or Twitter, Facebook, and Instagram in English account. And you may know we also have Galaxy Cruise English account. So please follow us. I stop my screen. Okay. So our journey is still ongoing. Please enjoy classifying many galaxies in season 2. And as Makoto-san introduced, please enjoy checking your answer with simulated galaxies. Okay, so our live stream in English is almost ending. Makoto-san, would you like to send some message to season astronomers?
Yes, but every time I feel very surprised in the Galaxy Cruise result because Galaxy Cruise achieved the great progress to increase the number of the classification, and one astronomer cannot do that. And the statistical analysis says that on the evolution, the picture of the galaxy evolution, which I don't know and I do not expect it. So like what you found in our special campaign, some very ancient old collisions can be found. This is a result of your effort. And I really appreciate all of the participants in this project and the Subaru Telescope. And yeah, my hope is that everyone enjoy for classifying the galaxies and checking the beautiful images of the Subaru Telescope. So
Thank you,
thank you very
Makoto-san.
much for this.
Yeah, thank you. So Makoto-san joined us when he was a graduate student as a junior officer, and he helped us to post many images at Galaxy Cruise Twitter, X, and then now he got PhD, and now he studied postdoc career, and now he's leading the Simulated Galaxy campaign and analysis too. So yeah, thanks to your excellent classification, Makoto-san, Captain Tanaka, and other scientists are excited and have a new discovery. Thank you so much for joining us. So we have to see you again, and please enjoy Galaxy Cruise, especially August campaign. Mahalo nui loa. Thank you so much for watching our live streaming. I hope to see you again. Mahalo. Goodbye. お疲れ様でした。これで終わった。じゃあ、ちょっとこれ抜けて、 あの、